Thanks, Mark. So, hi, I'm Dom Colsen. I'm a senior solution consultant with ServiceNow. I specialise in IT operations management, AI ops, luckily enough for today, and also strategy. I'm going to co-present today with a partner of mine, Kishor. Kishor, do you want to introduce yourself?
Thanks, Dom. Yeah, I'm Kishor Patel. I'm also a senior solution consultant in ServiceNow. My areas of expertise are IT operations management, AI ops, and visibility. I have over 13 years of experience within the IT industry as well.
Thanks. So hopefully what we're going to do today is we're going to take some of those concepts that Duncan spoke about and Barclay spoke about and try and bring them to life for you. And more specifically, how we at ServiceNow handle that and how we do that. And okay, if we look at the word, first of all, AI ops, if you break it down, artificial intelligence, pretty comfortable that everybody understands artificial intelligence now after the first two sessions. And the second part is operations. And what we've seen about maybe 7 years ago, is that the C-level was starting to get budget for AI ops. So they had this pot of money that they knew they had to spend in AI ops, but they didn't even know what it was. So they were saying, we've got this money, we don't know what AI ops is, we don't understand it, we don't know where to spend this money to get the most bang for our buck. And what we really looked at with those organizations then was understanding what the value of AI ops was it to them. And what we really identified, it wasn't just artificial intelligence in operations, it was really artificial intelligence around services and service delivery. And I'll come on to that in a bit more detail. Yeah. So we at ServiceNow then came up with a concept of actually AI-powered service operations, which is really taking the service desk, the ITSM function, and bringing that into the operation function and getting the value out of both of them. So when we talk about AI ops at ServiceNow, we're really talking about the consolidation of both service and operations. And when we looked at operations in its entirety, we looked at where can we apply artificial intelligence. And what we've seen realistically, the benefits were that virtual agent, and Duncan spoke about the chatbot. Yeah, so having the ability to intercept the user before it even reached the service desk. So having a chatbot that had the ability to be able to provision services for you, to find remediation for you for users. A prime example is password reset. So we've done this with lots of organizations now where we've completely automated their password reset process through the virtual agent. So the end user doesn't even have to speak to the end agent. But what we do with the operations side is we wrap around the AI ops on that. So what do I mean by that? We look at the patterns of password resets. So is somebody ordering, if we had 10 password resets this month or today, and yet tomorrow we had 10,000 password resets, do we have an underlying infrastructure problem that we need to address? So we're using AI ops to identify that underlying infrastructure as well. In Service Desk, we're also using Agent Assist, which again is giving that ability for the end user to self-serve themselves. Yeah, and we do that through custom portals and all that good stuff. And more importantly, it's the AI search. Now, this is the Google experience, if you like. It's where a customer can come in, or one of your customers or clients or consumers can come in and they can search in the service desk, say, I have a problem with X, and hopefully we do the AI machine learning in the back end to pull back what the most relevant article is for that user. So that was the service end. So then we looked at the operational endpoint from it. And from the operational endpoint, we've seen that we had a lot of health noise in there. We had a lot of events metrics in there. And things like that we need to do artificially. And we started looking at fingerprinting and mapping services. Yeah. So now what we do, we discover and map services through artificial intelligence across into the service desk. So now we're not just looking at how infrastructure impacts service, we're looking at technical services as a whole. And we're doing that through artificial intelligence. So we're doing artificial intelligence to discover the maps and services. Okay. And we're looking at event alert and correlation. How do we bring all those events, alerts, and correlation together? And we'll talk about that. And then finally, we're looking about predicting and looking at health logs. So not just the events and the metrics, we're looking at health logs as well. And how can we predict that something is going to fail in the future? Yeah. And this is going to reduce issues and identify anomalies. Yeah. So when we bring that all together, what we get is we get a AI-powered service ops environment, which is basically what we're doing is we're moving from a ticketed functional service to a real service. Yeah, is to understand how do I provide a service, and I'll come on to talk a bit more about that. We're talking about route alerting incidents to the right place. And I'll talk a bit more about, and we're talking about identifying with automation in clusters. Yeah. And not only that, we're also, how do we predict change risk? Because now we have all that data on a single platform, we're able to do that. And I think Duncan spoke about it slightly about a platform, and that's the whole point with Service now. We give you the workflow integration on the same platform, machine learning, AI analytics on the same platform. So it's the same algorithms we're working in the service desk and the operations side on the same platform. We're giving you a single source of record, and we'll talk about this in more detail, but that is crucial. That is incident, problem, change, risk, events, metrics, and logs, all on the same record. Yeah. 10 years ago, I would have said, don't send me any event you don't want me to raise an incident for. And don't send me any event you don't want me to raise an incident for that you cannot action. Yeah. So if you're just going to raise an incident and not close it off, then you can't action it. That was 10 years ago. Now with AI-powered service ops, what we're saying is send us everything, and we'll use the machine learning to tell you where your root causes are and what you need to resolve quicker, which will identify where your actions are. And then once you've got that single source of record, you've then got a single source of action. So not only once we found that incident or problem or change, how do I action that quicker? And I'll come on and talk about that more about it. And again, a single platform where you develop all the tools. So that's what AI-powered service ops is. Why do we need AI-powered service ops? Okay. Again, 10 years, when I first started 30 years ago in the industry as an ops analyst, I would have said to a customer, how many services do you have? And they would have probably said 5, 6, maybe 15 at the max. If I ask that question now to any organization, say, how many services do you have? You're looking at 5,000. And some organizations don't even know how many services we have. So you need AI ops to identify that services. And what we're saying is that digital services has exploded now. And I call it the Google experience. Google ruined my life. 30 years ago, when a user would have an issue with a service, they would say, okay, something's wrong with the service. I'll go off and make a cup of tea and see if it's okay when I get back. Those days are gone. Google have killed those days because Google's never down. Google, it's always up, it's always available, it's always performing correctly. Yeah. And more importantly than that, the functionality that Google gives you is that AI search underneath to identify what you're searching for. When was the last time that what you was looking for wasn't in the top 3 choices of Google? Yeah. And we take advantage every day. You will search Google probably 10 or 20 times today, and we just take it as these things happens underneath. Underneath that is all that artificial intelligence going on. And people expect that now from every business service. Yeah. So whatever business service they consume from you, they expect that. So services have just exploded, and they've gone even faster since the pandemic. Yeah. So people want to consume more services. There are some issues around that. One of the main issues around that is services have become more technical aware. Yeah. So they're spread across multiple technologies. They're more difficult to monitor now, those infrastructure and services. Yeah, and too much time is now spent firefighting instead of delivering the service. And more importantly than that, for most organizations, they see a lack of real visibility. Yeah, so again, we know we've got services out there. We don't even know what those services are. How do we map those services? How do we model those services? So that is why we need AI-powered service ops. It's just the growth in value. Yeah. And what we are really looking at back end is the volume of machine generated incidents compared to people-generated incidents. And there's a few numbers on this slide, and I'll talk around those numbers. The 2080, now this is a 2080 rule. For every 20 human-generated incidents that you will get in your organization, most organizations will have 80 machine-generated incidents. Now, that 80 machine-generated incidents is not going to go down. The volume of those machine-generated incidents is only going to go up, which is causing organizations to have more noise to be able to deal with. Yeah, and that's going in one way. And going back to AI ops is not about replacing people. AI ops is about doing the function quicker. Yeah, because that function's only going to grow. So when you start scaling up those machine generated incidents, so these are your third-party tools telling you have an issue somewhere. When you start scaling those up, what's going to happen is you're just not going to be able to scale your organization. I worked with a large financial organization the other day, and they'd done a takeover of another firm. And basically what they identified was they were getting 1 million events per month. 90% of them were machine generated events. And they had to employ a whole team just to close down those machine generated events with no fault found. So there was getting no value out of the data whatsoever. Okay, so when we looked at machine learning for those guys, it was an easy case for us to say, look, if we can reduce those events by 90%, that's going to mean you can have a lesser team. You don't have to grow that team. Yeah, and the people on that team can go and do more feature-rich functions for the organization. So the volume is going to go up, and that's only going to go one way. The other numbers that you see on this slide is the 25, 50, 15, and 10. So we've done some work with some analysts, and what we came up with, out of the mean time to repair, this was the number. So at the mean time to repair, 25% of the time, most organizations didn't even know they had a problem as a service level. They knew they had a problem at the infrastructure level. So the server guys knew I had a problem, the network guys knew I had a problem, the database guys knew I had a problem. But as a service level, 25% of that mean time to repair, you don't even know you've got a problem. The second number is 50%, is they don't know who owns that problem. So this is where you're sitting in war rooms for days, and we've all been there. It's not a network issue, it's a server issue. It's not a server issue, it's a database issue. It's not a database issue, it's a network issue. And 50% of that mean time to repair is just sitting in those war rooms. It's just identifying who owns the problem. What is the root cause of the problem? And again, we're using machine learning to identify the root cause, and I'll come into that in a bit more detail. The 15% was fixing the problem, was the automation of fixing the problem. Once you know you have a problem, once you know where the problem resides, the subject matter experts in your organizations can fix it really quickly. And that's why the 15%. Yeah, and the final 10% is to notify your consumers. Yeah, so mean time to repair, 10% of that time is just notifying your consumers either A, the service is down, or B, the service has been restored. So if you had a single platform that we did all this on, then obviously the consumers can log in and see that from thinking. But what we did, we looked at that number and we said, if we can just address the first two biggest numbers, the 25 and the 50, to identify problems in services quicker for you, and to identify who owns the incident quicker for you through machine learning, then that's going to cut down on that mean time to repair. Yeah. Okay. So how do we do it? Yeah. So how do we really do it? When we come to service now, everything comes up to a business service. Everything boils up to a business service, because that is the so what question. So what if I lose a bit of infrastructure? What does it really mean to me? We look at, so it means, what is the impact to the business? How is this going to impact my bottom line as a business? And it doesn't matter which organization you go through. Yeah, and it doesn't matter which room you take. It could be risk. How's that going to impact my business? It could be IT infrastructure. How's that going to impact my business? So within service now, everything boils up into a business service. Yeah, and we identified that not all business services are critical, because now we've got those 5,000 services. So we need to identify which ones are critical to you as an organization and which ones are not so critical. And then this gives you your subject matter experts time to triage the critical incidents instead of looking at the non-critical incidents, because they understand the impact to a service. Yeah. And we understand that each service is underpinned by infrastructure, and that infrastructure could be cloud, application, data, container, service, and infrastructure has got more and more complex over the last 5 to 10 years, especially now where you have serverless configuration. How do you monitor a serverless function? Yeah, and all that data is now coming through in real time. Yeah, and it's coming through logs, events, and metrics. Yeah, so we're getting a lot of noise now from all that infrastructure. And this was the 80-20 rule. How do you handle all that noise? And we're not just talking about events that's happening on the system. We're talking about metrics, because it's now no longer good enough to have a 99.5% uptime. People expect that from organizations. They also expect it to be performing to peak performance. Yeah. And with all this noise that's coming through now, how do you analyze that? And then you've got that human generated noise as well: incident, change, problem, and risk. So all this is coming through to your service desk tool. All this is happening on this, or should be happening on a single platform. Yeah. And what we do is we take that noise is coming from multiple tools. Yeah. Now, an analyst, a top analyst we spoke to the other week, they said you shouldn't have no more than 3 tools in your tool chain to diagnose a problem. Anything more than 3 tools in your tool chain is only going to take you longer to diagnose. If you're cross-launching from SolarWinds into Datadog, into Splunk, into Apps Dynamic, and you're trying to do all this in isolation in teams, it's going to take you longer to resolve that instance. And that's that 50%. Who really owns my problem? What is my root cause? Who should be fixing it? And how do we identify that? So you're getting all that noise from all those third parties. And then go back to what I said originally, we want that noise now. Historically, we would say, don't send me anything that you don't want me to raise an incident for. What we're saying is send me everything and we will sort it out. So how do we sort it out? We sort it out through any source AI ops in our artificial intelligence. And the first thing that we look to do is we look to reduce the noise. So we look to take all those events that's coming in from all those third parties, from all those infrastructures, and reduce that noise through the machine learning. We use an algorithm, it's a clustering algorithm that we use that basically reduces that noise to 90% reduction. Yeah, and again, this is no rules based. So we don't with AI ops, we don't expect you either to go in there and tune the algorithm. In fact, you cannot go in there and tune the algorithm because the algorithm is complex. What we can do is what we call reinforced learning. We give you the ability to be able to tell the algorithm to reward the algorithm or not reward the algorithm. Reinforced learning is just like a small child. When a small child does something good, then you give the algorithm a reward and it will carry on doing that. When a small child does something bad, you punish the algorithm and the algorithm will learn from that punishment. And that's what we do with the algorithm. But out of the box, 90% reduction in noise, yeah, without any rule base whatsoever. We do some event management correlation out of the box as well. So the event management correlation is that interface up, interface down. So if the interface goes down, we'll wait a certain time, a period of time before if we get an interface up, then we won't raise you an incident. So we're stopping raising the incident at source there. Yeah. And then we've got actionable alerts on incidents. So once we've given you that group to alerts on incidents, we can then action them. And we do these over advanced correlation, cluster and pattern detection, as I said, and we'll talk about slightly bit more on that. We do it about metric anomaly as well. So when we look at the metric anomalies as well, we're taking in the feed from the metrics and we give it what's called a confidence band. So you're not even telling us if this metric goes over 95%, yeah, do something. You can do that, but we don't like you doing that. What we say is we'll give it a confidence band. We'll learn the history of the metrics over time. We'll run those patterns and clustering on the metrics, and we'll identify ourselves when that metric is above norm, what we expect. And then we do the log analytics, and we'll come on to that in a moment. Yeah. And then what that gives you then is it gives you the outcomes. It gives you the ability to predict. So no rules or thresholds needed. And it's a language-based anomaly detection. It gives you the event identity to prevent. So we identify root causes. Yeah. And we see with most customers, when they do it on a single platform, when they adopt the AI ops services, as Duncan and Barclay spoke about, we see a reduction in 35% in P1 incidents. Yeah. And we see that 40% increase in mean time to repair because we're addressing those two big numbers right at the beginning. Yeah, with machine learning. And then finally, you've got your automation. So what we're saying here is automate, and Barclay talked about automation, automate on intelligence. And that's exactly what we're saying here. You don't need to automate everything. Automate on the insights that you find from this thing. And again, password reset is a prime example. Yeah, if we were doing password resets on a chatbot level and just resetting 1,000 passwords and you wasn't using any machine learning in there, you would never understand you had an underlying infrastructure problem or an underlying application problem. And then once you understand you have an underlying infrastructure problem or application problem, then you can automate on intelligence. Okay. And then finally, what you'll get onto is self-healing networks. And we don't see a lot of customers doing this. But once you've got that automation done, then let the automation run in the background and let this go and fix your infrastructure without any human intervention. We don't see a lot of organizations doing that at the moment because they don't trust AI at the moment to do it. Or more importantly, their processes don't fit within that at the moment. But we are going to see that move in the next 5 to 10 years. So how do we do the predictive side? So that's the predictive. How do we do the prevent side? Now, the prevent side is really what we want to do is we want to identify you have an issue with the infrastructure way before you have an incident or an event. I call it an event horizon. So way before that server falls over, the disk space fills up, we want to identify from the logs in the log file where we have the issue. And again, we take the logs in from multiple sources. This includes our own log agent. We can do it from Splunkbit. And again, these logs are coming in. And most of these logs now are being streamed in. So they're coming in. Going back to the second slide, I call that the 4 Vs. You have to look at, let me go back. Yeah, at this slide, I call it the 4 Vs. You have to look at volume. How quick is it coming in? How much are you getting? Velocity, how quick is it coming in? Now, the velocity at one point wasn't an issue. Now where you have open telemetry and streaming data, the rapid pace that it's coming in is impacting. We have an organization that's sending over 2 million events, if you like, logs or metrics per day. So how quick is it coming? So the volume, velocity, variety, where's it all coming from? Yeah, it's not just human generated, it's machine generated as well. And the final one, which is the most important one, is the value. And going back to where we say we've seen this C-level with the AI ops budget, we look to it from a value point of view. How do you get the most bang out of that book? And it's the value. And the value really is to predict, prevent, and to automate. Yeah. So again, how do we do that prevent? We get the logs coming in from the system. And then we then run the log analytics on it. And it's the same algorithm underlying everything. It's a clustering algorithm that we use. We parse the file logs. So you don't even have to tell us if we're looking for a specific word in a log. We will learn the patterns in all the log files. Yeah. And we'll identify those patterns. So one of them could be a server address or a server profile or a HTTP status. And we will learn that pattern over time. What is the norm for that pattern? So HTTP status, if we're seeing 200 and we're constantly seeing 200, we'll accept that as a norm for the pattern. Then all of a sudden, if we see 400 or 401 or 403, that's above norm. So we'll say, okay, this is above norm. So then we'll raise it. And we also, when we look at above norms, those are anything above norms, we also look at below norms as well, because we have that pattern now in the system that's being constantly run on 30 days worth of data. Yeah, we can look at where would the anomalies done. So if it's normally at 200, and then all of a sudden we see the 200 drop, we'll raise that as an anomaly. Yeah, so we're not just looking at when it breaches, we're looking at when it also doesn't breach. Yeah, and we're looking at new. So when we see new things in those log files, so this gives you the ability to identify issues before they actually happen. Yeah, a real world example to this is if someone goes and changes some code on a piece of software, and in the non-prod system, they are doing some testing, so they turn on some trace files, they push that configuration into the production system, and those trace files are still left on. Yeah, what will happen is we will see a volume growth in the log file. We'll detect that volume growth in the log, which fills up the disk space, which causes the server to stop working. We'll detect that log file's grown from norm, and we'll raise an incident for you to say, look, this log file's growing. So now we're predicting that something's going to happen. Yeah, we cannot, and there is no system in the world or no algorithm in the world that can predict that piece of infrastructure, that server will fail next Thursday at 3 o'clock. We can't do that. We can give you a probability. Yeah, we can say, look, from what we're seeing on the logs, we think that you're going to have a major issue, incident, or an event on that server at some time, or that bit of infrastructure at some time. And that's the prevent side of it. Key takeaways is really, it's about, for us, it's about reducing noise and reducing incidents. And that is what the AI-powered service ops is all about. It's about taking that AI, artificial intelligence budget that we've got and helping your organizations be able to see the woods from the trees. Yeah, that noise is only going to go one way. You're only going to get more machine-generated noise. More important than that, it's identifying service impacting. So it's the ability for us to say, look, this infrastructure underpins that service. And through machine learning, we can do that. Through the conversation patterns, we can do that. And then we can say that service is going to have an issue because of that. And then automate on insights. So actually do intelligent automation, I call it. Do the automation where you're going to get the most bang for your buck from. And more important than that, it's all about reducing mean time to repair. It's all about identifying where you have an issue, where you have an issue, who owns the issue, and what they do with the issue. Okay. And with that, I'm just going to pass on to the next phase. I will take the questions. There are some questions in chat, and I'll have a look. I'll pass on to Kishor just to finish how we do that with a real world customer.
Cheers. Thanks, Tom. You have to move it to the next slide. Thank you. So we have a large global travel organization, public cloud infrastructure. They had 50,000 Azure resources, 1.8 million Kubernetes components. This was running over 800 services in that environment. But that infrastructure was generating 2 million events a day. And they were able to, with AIOps, reduce the noise by 99.8%. This is a real life example. I've got two screenshots of the environment. And you can see on the left, it was before, and on the right is after AIOps. But on average, we're seeing around about 70 to 90% noise reductions overall. And AIOps is either helping to prevent or helping to resolve these issues much quicker. And this is actually having a positive impact on your employees, because this is now giving them time back to focus on high value and meaningful work, time to grow and upskill, and time to actually recharge. And when the workforce tastes a bit of that, it just leaves them hungry for more. And with that said, Dom and I are happy to answer any questions you may have, and thank you for your time.
So there's a couple of questions in the chat. Let me see if I can open that. I
think that one's been responded to.
Yeah, I responded to that one.
Yeah,
okay.
Thanks very much indeed, Dom and Kishor. It's great to see how that things we were talking about in the first half really work as you go through the tool set and see some actual customer success stories at the other end.